Hello, welcome to Fagor CNC 8055 MC Profile Editor Lesson number 7, Multiple Profile Pockets. In this lesson, we're going to learn how to make multiple profiles using the pocket command, which is found under the F5 key. And again, I'll be using my simulator software, and you'll be using your 8055 front panel with your enter key, your recall key, your escape key, up and down arrow keys, and the F5 key to launch a 2D pocket cycle. Let's take a look at a sample blueprint. Here in this sample part, we have our origin of our part 0, 0, and then we have a pocket, which is defined by two center radiuses. 1 inch radius, 1 inch radius, and angle of 135 degrees. And here we have an exact copy of that offset at 4 inches below it. Let's go ahead and enter this data into a profile pocket profile editor. Let's begin. Let's begin by pressing the F5 key. And here we're on level 1 profile pocket 2D. Over here we have the profile number. If I press the down arrow key, we'll see that we have 3 previously drawn parts in here, and we could either go with number 3 or number 6. I'm going to go ahead and program number 6 and then press the recall key. You'll press the recall key on your 8055 front panel. This opens up a blank profile editor screen, and we're going to go ahead and begin by pressing edit and profile. And let's take a look at the part print again. And in this case, since we're cutting a pocket, we're going to want to cut counterclockwise around the inside of this part for climb milling direction. And from lesson number 2, we learned about how to pre-plan an entry point or a beginning point. And we're going to go ahead and pick this point right here as a starting point. We know that the center is at x2, and we know that the center here is at y-2, and with a 1 inch radius we can project that up to be -1 in the y-axis. So this will be a very easy starting point for us, and then we'll continue drawing in a counterclockwise direction. So our first Cartesian point will be x of 2, y-1. Here's our preview, and we're going to validate it. Next, we can see that x remains the same, but y is going to go to -3. That'll be -2 plus -1. So we're going to do a counterclockwise arc, and the x is going to remain the same, so I'll leave that blank. Y will go to -3. I know the center is at x2 and -2. And here I don't even have to fill in the radius. It already has enough information to solve this. Validate. Next, we have a straight line coming off, but we don't know where the intersection point is. The profile editor can solve this for us. So we're going to draw a straight line. I don't know where the x. The y actually is at -3. The angle is going to be 0 degrees, and I'm going to choose tangency with the F6 key and validate that. And you'll see that the line turns a dotted white, which means that it's still incompletely solved. Next, we have another line coming off an angle. Here we have 135 degrees, so basically this line would be 45 degrees minus. And it'll be tangent to this arc. Let's go ahead and enter in that data. So we're going to do another straight line, and this time I don't know where the x2 or the y2, but I do know the angle is -45 degrees, and I'm going to go ahead and validate it. So here it accepted it as an incomplete step. You don't see a dotted line because it doesn't have enough information to actually display or preview that line. The next step after that is another counterclockwise arc. And the arc is going to be around this center of x 4.707, y minus 3.121. Let's enter that data. So a counterclockwise arc. I don't know where the x2 or the y2 is, but I do know that the center is at x 4.707 and the y center is at minus 3.121. And I do know the radius is 1 inch, and I know that I want it to be tangent to the previous line. And I'm going to validate that. And now it turns green. And this is because there's multiple choices. So I'll press the next key. Here it is. This is the correct choice. So we'll press enter to choose. And you'll see that the profile editor solved this intersection here, and also the tangency point to this arc. So now we have an arc in dotted line, which means it's incomplete, and we're going to need to draw a line off of that. So again, we're going to draw another straight line, and let's take a look at our blueprint, and that'll be 135 degrees. And I don't know where this intersection is. So really all I know is it's tangent to this arc at 135 degrees. Let's enter that data. So x2, I don't know it. y2, I don't know that information. Angle, 135 degrees. Tangent, choose F6 and validate. And it's now solved this tangency point. And here we have a line. It's running continually up in this direction, but again, it doesn't have enough information to display it. So here we have choices. So if we go to next, this is the correct choice. Enter. Okay. And the final element will be a line running from here back to our beginning point of x2, y minus 1. And this will be traveling at an angle of 180 degrees. So I'll draw another line. Okay. I know the x2 is at 2 inches and the y2 is at minus 1 inch. I know the angle is 180 degrees, and I'm going to validate it. There. This first part is complete. So this gives us one part. But now we can press the F4 New Profile, and we can start another profile. So let's go to Profile again. Our initial Cartesian point, if you remember, this was minus 1, and we're going to be exactly 4 inches further minus in the y direction. So x will remain the same at 2, and y will become minus 5. And I'm going to validate that. We're going to do another counterclockwise arc. X remains the same. And y2, if you remember, went to minus 3. Add 4 inches to that, it'll be minus 4. x2 remains the same. y2, if you remember here, we went to minus 3. If we add minus 4 inches to that, it'll be minus 7. X center is 2 inches. And the y center will be minus 6 inches. We don't even have to put the radius. It has enough information to solve it at this point. Validate. Next, we're going to do a straight line. I don't know what x2 is. I know that y2 is again minus 7 inches. And we're going to be traveling at an angle of 0. And it is tangent to the previous arc. Validate. And again, it turns to a dotted white line. Next, we need to do another line here, and if you remember, it was at that minus 45 degree, so I'll do another line. x2, I don't know it. y2, I don't know it. The angle, I only know that it's minus 45 degrees, and I'll validate it. Okay, and again, we can't preview it because there's not enough information. Next is arc. x2, I don't know that information. y2, I don't know that information. The x center, I do know, is at 4.707, and the y center over here was minus 3.121. If I add 4 inches to that, that would be minus 7 0.121, and the radius is 1 inch, and it is tangent, and validate. And here we're given choices, and again in green, next. This is the correct one. Enter it. Okay, now we have our arc. Now we need to draw a line off of that. If you remember, that's 135 degrees, that line, so we're going to draw a straight line. I don't know where the x2 or the y2. I do know the angle of 135, and I do know that it's tangent to the previous arc. And I validate it. And again, it's in green. Next. Next. This is the proper one that we want to choose. Let's press enter. So we still have our line traveling here, even though there's no preview of it. Now we just need to do the finish line back to our starting point. Straight line. X2, I know that, of 2 inches. Y2, I know that to be minus 5 inches. Angle, 180. That's the direction of travel of the line. And if I validate it, this project is now complete. So at this point, we're going to go ahead and save and continue. Hit escape twice on your keyboard. We're going to press the finish key. We're going to name this project. We'll name this Pockets 2. Okay, if we look in the library by pressing the down arrow key, you'll see here's our project that we've already saved. The X and the Y coordinates here are shifting coordinates, where you can actually shift this pocket to a new 0 location by using these coordinates. We're going to go ahead and go by blueprint at this point, so we're going to leave these blank. Here I've already filled in the Z start of 100 thousandths, Z begin of cut at 0. The depth of this project is 125 thousandths deep, and it's going to take it in 2 depth of cuts. A plunging feed rate of 5 inches per minute. No coolant. Feed rate of 20. Spindle speed. Tool. And here is the entry angle. At 90 degrees, this will enter into the part as a plunge. If I were to put 5 degrees, it would do it as a ramp. I'm going to be using a 1/2 inch tool, so I'm going to use a 0.2 step over. Here we have a finish feed rate, finish RPM. We're using the same tool for rough and finish, and again the 90 degree entry into the part is a plunge. And I'm leaving 10 thousandths on the sidewall and 10 thousandths on the bottom as a finish pass. And here N is the number of sidewall passes for finish. So this will go 2 depth of cuts for the finish pass. Let's go to the graphics simulator and take a look at this part. Press graphics, clear screen, cycle start. I'll press the F2 display area and optimize it. And here you'll notice that both pockets were completed. But the first thing that you'll notice is that the pocket cycle did not follow the order of programming in the profile editor. If you remember, I drew this profile first, so logically you would think that it would cut this profile first, and then it would cut this profile second. But it actually works from the last one drawn back to the first one. So it did this one first, then jumped to this profile and did this one last. So that's something to keep in mind. If you're doing a profile under the F3 key, it'll follow the order in which they're programmed, from the first one to the last one. And in the pocket, it's exactly the opposite of that. It's going to do the last one first and then work towards the first one that you've drawn. And you'll also notice that we have some purple lines here which are rapid moves, which means that after it's done cutting the pocket, it will automatically retract the Z and go to the next pocket and perform the same operation. And if we zoom in, you'll notice that we automatically get an automatic ramp on and a ramp off as part of the pocket cycle. You may have remembered from lesson number 3 that when profiling, we have to add this manually. But when you go to the pocket cycle, the pocket cycle automatically calculates a ramp on and ramp off based on your tool size. So this is a nice feature of the pocket. Okay, let's look at a second part example where multiple profiles are used while cutting pockets. In this example, again, we have 0, 0 as our part origin, and we have this pocket that we want to cut out. And in this pocket, it has an inverted radius, an external radius, it has a corner blend, and it actually has an island in the center that we're going to cut around. So this feature is an island. So while we're clearing this pocket out, we're going to have to machine around the island that we define. So this will be a separate profile defined in the pocket profile. So we can start here at the beginning of the pocket, which is at x1, y minus 1. And with pocketry, there's no need to worry about nesting a tool in a corner for a start. The pocket cycle will run perfectly fine with this information because it knows that it's on the inside of this profile at all times while it's performing the cutting. So let's go ahead and see how to start this project. Okay. So we're back up to the profile number, and the last one we used was 6. We're going to choose 7 this time, and we're going to press the recall key. So now we get a new profile editor screen that opens up blank. And I'm going to go ahead and press Edit, Profile, and the Cartesian point, if you remember we just talked about that, was going to be x1, y minus 1. There's a preview of our point. We're going to validate it. Next, we also want to cut around this part in a counterclockwise direction on the inside for climb milling. So after you've defined your initial starting point, it's very important that you choose the flow of your profile lines so that your cutter will follow these while performing all cutting motions. So here we're going to go to x2, y minus 5. Straight line, x2, y minus 5. Validate. Next we need to do another straight line, but we're going to skip programming this radius, and I'm going to show you a neat trick in the profile editor which is called Boolean add. And this feature that I'll show you in a little bit will actually add this portion later to the profile after we draw it. So we're going to go ahead and just project to this point right here, which is x6, y minus 5. Another straight line to x of 6, y minus 5, and validate it. We're currently here, and again I'm going to draw another straight line, and also I'm going to skip this radius. And later I'm going to show you another neat trick which is called Boolean subtract, where we're going to add this shape to this profile later. So I'm going to project up to this point, which is x6, y minus 1. Straight line, x6, y minus 1. Validate. Back to the blueprint. We're currently here. Now we need to draw another straight line back to our origin of where we began to x1, y minus 1. And when you're drawing profile shapes that are to be pockets, they must be completely closed where the beginning point and the end point are exactly the same. x1, minus 1. And validate. Okay, this completes this shape. Now we can go ahead and we can put this blend radius on using the corners feature. And that's 0.75. So I'm going to hit the escape key twice, modify, corners, rounding,
And here it's already highlighted in red, the correct corner. I'm going to type in 0.75. There's the feature. I'm going to escape. And now I'm going to press the edit key again. And now we're ready to begin programming our next profile. Let's take a look at our next feature. Here we have this island. And this island is just a regular rectangle beginning at x3, y minus 2.5. And it's 1.5 inches long, and it's exactly 1 inch wide. So again, a rectangle beginning at x3, y minus 2.5, we can enter this in a different way. Here we have, on top of the profile feature, where we can draw each line and arc individually, we can also draw regular circles and rectangles that can be added as additional profiles. So let's choose rectangle. And here it wants to know if the rectangle should be clockwise or counterclockwise. So we're going to be cutting around this profile in a counterclockwise direction. But when we cut around the pocket for a finish pass, we want to go clockwise. So this is the correct choice. You could also change it here with the F6 key. So the x1 beginning point is x3, and y1 is minus 2.5. And if you remember, I said the length was 1.5, and the length in y is minus 1. And there's the preview of our rectangle. And this looks correct to me, so I'm going to validate it. We've just drawn our second shape, and this is an island within inside of the pocket that we'll machine around. Okay, let's take a look at our blueprint again. Okay, I promised to show you a neat trick down here, and this one is called Boolean add, where if I simply just draw a circle that overlaps this profile, it will either add or subtract to it. And this is a 1 inch radius. The center is at x6, y minus 5. Let's go ahead and enter that data now. So I'm going to add a regular circle, and the circle, I want it to go counterclockwise with the direction of the shape that it's going to overlap. So I'll change that to counterclockwise. And x1, I'm going to need to plot a point out here. So if this is x6 and it's a 1 inch radius, I'll make that 7. And y minus 5, x center will be at 6, and minus 5. Okay, it automatically changes to a 1 inch radius. Okay, here you can see that I have an overlapping circle with a starting point that's outside of this shape. And that's exactly the rule. If the starting point of this circle is outside of the original profile that it's crossing, it adds to it. So it will simply add this portion to the profile. I'm going to go ahead and validate that. Okay, next. Up here, the next feature is Boolean subtract, where I only want to keep this portion. I'm going to make an overlapping circle, but I need to have the start point on the inside of the profile, so it will subtract the radius portion. And again, this is at x6 and the x, but the y is at minus 1. Let's enter this data. So another circle, and this circle, we want this circle to go clockwise. x1, I'm going to go ahead and, if this is at 6, I'm going to plot it at 5. Y minus 1. X center is at 6, minus 1. And you can see that it's solved. Now this start point is now technically on the inside. It's right on the line, but the cycle will take that as being on the inside. If this were anywhere on the outside, it would add. If it were anywhere on the line or on the inside, it will subtract. Let's validate that. Okay, I'm going to press the escape key. a couple of times. I'm going to press the F3 display area and optimize so we can get a better look at what we've drawn. So here we have our original profile shape running around in a counterclockwise direction. We have a rectangle drawn in the center as an island in the clockwise direction. We have an arc going in the counterclockwise direction and an arc going in the clockwise direction. Okay. We're going to save and continue. We're going to finish this project, and we're going to name this one Profile 3. Library by pressing the down arrow key. Here we've got Profile 3. Enter. Okay. Let's now press the Graphics Simulator key to see how this project will complete itself. Clear key. Cycle start. Very nice. Here you can see that we machined not only around the inside profile, but we also machined around the island and applied finish passes to both of those features. Here is the Boolean add, where we added this portion by an overlapping shape, and here is the Boolean subtract, where we subtracted that portion by making the start point of the circle inside. You could also do the same feature on an island. You could add a Boolean add or subtract to an island, and you could also do a Boolean add to a Boolean add, where you could have multiple shapes overlapping each other. I hope you found this informative. This completes lesson number 7.